Sharks have very sensitive electroreceptors called ampullae of Lorenzini.
The shark actually can sense small electric fields in the water, and this happens because ions from the water are able to pass into its organ. Our material functions in a similar way in that ions from the water transport into the film, and we're able to detect that. So the material we're measuring is samarium nickelate, and it's a quantum oxide material, a material that's going to have the ions change valence state. It can hold the same composition, but the ions can exist in different valences. So for example, in our material, we have nickel 3+, and it changes to nickel 2+.
We use physical vapor deposition method to grow this material. So we deposit thin layers on various kind of substrate, like lanthanum aluminum and silicon substrate. So we put it into a very high pressure, many times than our atmosphere. Then we put it into the high temperature and hold it for, anneal it for like 1 day to get this sample done. So this sample is not very easy to make.
There is a lot of interest in being able to interface electronics or semiconductors with biological media in aqueous environments. What we think is we found a material that can be both robust in the water environment, but also can interact with it. So we can sense the changes in the chemistry of the water, we can sense changes in the temperature, we can sense electrical fields. It's basically a system where you can dynamically interact with its environment. And one application of that is sensing, but I think there is a lot more to be discovered here.